So here we have chapter problems 6 through 12 for the quick quiz review on the Physics Honors Electric Force curriculum. So our first problem, two negative charges of 2.5 microcoulombs and 9.0 microcoulombs are separated by a distance of 25 centimeters. Find the directions in terms of repulsive or attractive and the magnitude of the electrostatic force between the charges. So before we dive into this question, we need to understand what's going on. There are two negative charges, which automatically tells us that they're repulsive because they have the same charge. We have 2.5 and 9.0 microcoulombs. We need to convert those to scientific notation. So when we plug into the formula, it will be easier to compute for the calculator, easier to input. And the distance, or the radius, is 25 centimeters. We're going to convert that to meters. We're looking for the electrostatic force, so we know that our final unit should be newtons. So I just pulled these questions out of the chapter problems. I changed up the numbers a little bit, so feel free to pause the video, try to solve this on your own before I move to the explanation slide. You can use that as an answer key, so more practice before the quick quiz. But remember, this is a short review. I will be briefly explaining how to solve these problems. So make sure you understand the concept, do some practice on your own, and even go to the professors for extra help if necessary. So here's the explanation. We are going to be using the Coulomb's law formula. This formula looks awfully familiar. Last unit we were working with gravitation, where we were looking for the G field between two objects. Our constant was G, 6.67 times 10 to the negative 11th. We had M1 and M2 and radius squared. So this formula shouldn't be anything new. It should be familiar. Working with it will be quite similar, just with different variables, different values. So F is the electrostatic force, K is the Coulomb's constant. This value should be on the formula sheet. If not, memorizing it won't do any harm. Q1 and Q2 are the charges, and R is the radius, or the distance between the charges. Remember how to convert your microcoulombs to coulombs using scientific notation. It will be beneficial to you when you are plugging into your calculator. Since we are only looking for electrostatic force, we do not need to alter the formula in any way. We can just plug and chug. We can take all of our values and just plug them in. Make sure you are plugging it in correctly. The right values are in the right places. Parentheses are used correctly, such that your calculator follows PEMDAS in the correct order. And your final answer should be 6.75 newtons. Remember, we are answering in newtons, and I can't stress this enough. Make sure you plug this into your calculator correctly. Problem 2. Two charges of +3 microcoulombs and -4 microcoulombs experience an attractive force of 8 millinewtons. What is the separation between the charges? So right off the bat, we can see that we are not solving for electrostatic force. We are going to need to do some algebra to the Coulomb formula to solve for a variable other than F. This is an attractive force. We can see that by +3 and -4. They have different charges, and 8 millinewtons. We need to know how to convert millinewtons to newtons by multiplying by 0.001. Make sure throughout the exam you understand how to convert different values to the standard units in physics, like centimeters to meters, millinewtons to newtons, microcoulombs to coulombs, and there's so many more. But make sure you know how to do that. The formula sheet should have the standard way of doing so, memorization is not needed for this concept. And let's dive into the explanation. So again, we're using the Coulomb's law formula. This time we are looking for the radius. We need to isolate R in the Coulomb formula. This is probably one of the more complicated questions where the algebra is more difficult. So we can swap F out for R squared and then square root it. So R should be the square root of K times the absolute value of Q1 times Q2 over F. Make sure you're using your calculator correctly when plugging in. There is a lot going on in this question, when it comes to square roots, parentheses, absolute values, and division. But once completed, the final answer should be 3.764 meters. Remember, I rounded to the nearest thousandth. If the test specifies in which decimal place to round to, then do so. If not, I think the hundredth should be fine in physics honors. And remember that the unit for radius is always meters. So this is it for a quick review. All of the questions have the general same idea of using the Coulomb's law formula. Make sure you understand how to use it. Make sure you list your knowns and unknowns in the question. It will be very beneficial to you as you understand what's going on in the problem much more clear. Be familiar with your calculator. Make sure you plug in the formula and all of your knowns and unknowns correctly. Otherwise, that wouldn't be so great. And yeah, just know how to use the formula, list your knowns and unknowns, and yes, know how to convert the value of microcoulombs to scientific notation. Also, be familiar with general conversions, and you should be pretty solid for the upcoming quiz. Again, this was a quick review. I hope you learned a lot or understood better. That was the point of this. So hopefully I will see you in my next video.